Hello Physical Science, this is Mr. B. We're continuing on here with section 1, a little bit of a longer section here. Remember, it's called ionic bonding. Remember, we ended yesterday talking about ionization energy, which is the amount of energy that actually an atom must overcome for one of its electrons to escape the pull of its protons. And we gave an example of how sodium and chlorine react, because chlorine just needs one electron to achieve a stable configuration. So sodium really easily donated its one electron. It has a low ionization energy. It doesn't take much energy for that to happen. And then we had the cations versus the anions. They formed what we called an ionic bond. So now we're going to talk about, basically the principles of how an ionic bond can form. So now we're going to talk about some rules for what we do when we actually look at a formed ionic bond. So first we're going to start with is the structure. So after two ions come together, they form their bond together, they form their ionic bond. Now we're going to look at how their structure, so what they're actually set up like, will affect its properties. So solids whose particles are arranged in a lattice structure are called crystals. So we will get, and this will make more sense here in a little bit. So a crystal is the formation of particles arranged in a lattice structure, and that's going to be something that's going to be associated with ionic compounds. So this will make a little more sense later on, but I would make sure I wrote it down now, and we'll dive more into it in a little bit. But again, just make sure you have it jotted down now. And the properties of an ionic compound can be explained by the strong attractions among ions within a crystal lattice. So the reason why properties are the way they are is because of how they're arranged in what's called a crystal lattice. Again, it gives them very strong attractions. And again, here in a little bit, we'll see an example of that within either this video or maybe even possibly the next. So compounds that contain ionic bonds are ionic compounds, and they can be represented by chemical formulas. So this right here, what we just went over, kind of put this on the back burner for now, and we'll explain that more. So now what we're going to talk about is kind of, again, the more general rules of kind of how ionic bonds are represented. So a chemical formula is, so I would definitely write this down, a chemical formula is a notation that shows what elements of a compound contain and the ratio of the atoms or ions of those elements within the compound. So again, we'll give an example and then I'll go back. So the chemical formula for sodium chloride is Na. So these are the two elements involved, Na and Cl, and this indicates that one sodium ion for each chloride ion is in sodium chloride. So that's what it's saying. It's a notation or just a representation right here, kind of shorthand, that shows what elements, so NaCl shows what elements a compound contains and the ratio of those atoms or ions of those elements in the compound. So this is kind of a bad first example because there's no numbers here. So this just shows us that for every sodium ion, there's one chlorine or chloride ion, because chlorine is a negative charge. Remember, we have to add the IDE to the end of the ones that have a negative charge. So just to give an example for the ratio, let's say if this was a different one, there could be a 2 here. That would show that there's 2 sodium ions, and if there's a 3 here, that would mean there's 2 sodium ions for every 3 chloride ions. So that's, again, this is a bad first example. It doesn't really show the actual ratios because it's 1-to-1 in this one. So now we'll go over an actual example that will kind of help this make a little more sense. So now we're going to look at the chemical formula for magnesium chloride. So magnesium and chlorine are what's going to be involved in this reaction. So here is our magnesium, and if you notice, magnesium has two valence electrons, so it has 2 dots here, and now you notice we have 2 chlorine atoms right here, maybe because if we look, magnesium is going to give 1 electron here, and it's going to give 1 electron here. So it's going to lose 2, but it will make 2 chlorine 2 chlorine atoms very happy. So now instead of just Mg+, we have 2+ because it donated 2 electrons, and each chlorine or chloride now has a minus associated with it. So what just happened here, this is an example of what just happened. It says a magnesium atom cannot reach a stable electron configuration by reacting with just one chlorine atom. So if it reacted with just one chlorine atom, now it's going to become, if we just took out this bottom half down here, then we're going to have magnesium with just one electron and a stable chlorine. So that's not going to make magnesium very happy. If magnesium is going to donate one, it's going to want to donate the other as well. So it must transfer electrons to two separate chlorine atoms. So that's what we're seeing right here. One electron's going to this chlorine atom, one electron's going to this chlorine atom. And after the transfer, the charge on the magnesium ion is now 2+, because it lost 2 electrons, and its symbol is Mg2+, which we have right here. Now our chlorines or chlorides are just a Cl-. So that's an example of kind of how a chemical formula is worked, and actually we'll give you our chemical formula right here. So the formula for magnesium chloride is MgCl2. So if you look right here, we have one magnesium atom, we have two chlorine atoms. So because now this what shows us for every one magnesium atom, there is two chlorine atoms. So the 2 is written to the right and slightly below the symbol for chlorine, and is used to show the relative numbers of atoms of the elements present. So if we can pretend that there's a 1 written right here next to the magnesium, but again, it's just kind of assumed. And one of the uses for this magnesium chloride is it's used to control dust on unpaved roads. So in class, we'll probably do some more examples for ionic compounds. Make sure you know the rules of, and again, this example is a good one because it shows us how the electrons move and the charges associated with each one. So that's it for this one. We will finish up section 1 tomorrow. Let me know if you have any questions.